Hello everyone, let's start with the next topic, which is basics of selection of emergency or backup supplies. Now we all know that electrical power system is three-phase AC operating at frequency of 50 Hz, and the power station delivers the power to the consumer through its transmission and distribution system. So now let us see what are the selection criteria for permanent power supply. And the permanent power supply is the one which we get from the electrical utility. So now let us see what are the selection criteria. So first is voltage regulation. A voltage variation has a larger effect upon the operation of power machineries and the lights. So the voltage fluctuations are should be less. If the fluctuation in voltage are sudden, then there may be unnecessary tripping of the circuit breaker and consequently interruption to the service. So the voltage variation has to be in limits. Next point is dependability. Now this is the important requirement of electrical system is to provide an uninterrupted supply, and if there is a loss of supply, then there is a huge loss to the industry and as well as the other consumers, which can cause irritation. So it is the duty of electrical supply company to keep the power system going and provide an uninterrupted power supply. Next point is balanced voltage. An unbalanced voltage, if supplied to the consumer, it will result in decrease in efficiency of the machineries, for example synchronous or induction motor, and also it results in decrease in its maximum power output. So a balanced voltage is to be provided, and one of the method of maintaining balanced voltage is by having balanced load connected to the circuit. Next point is efficiency. The efficiency of the system should be good because efficiency is related to the efficiency is nothing but output upon input, and the efficiency will be low if losses are more. So if the losses in the line and machineries are largely depend upon the power factor, and therefore it is important that the consumer have a load of power factor having low, then they should be penalized, and the loads of low power factor also requires greater generator capacity and produces larger voltage drop in the lines and transformer, which affects the efficiency. Next point is frequency. The frequency of the supply system must be maintained constant. It is because if there is a change in frequency would change the motor speed and thus interfering with the manufacturing operations. And the last point is free from inductive interference. The power lines running in parallel to the telephone lines produces the electrostatic and electromagnetic field disturbance, which causes the noise and hums. So it is important that the power supply should be free from the or power lines should be free from the inductive interference. So now let us see what are the emergency or backup supplies. An emergency or backup supplies is an independent source of electrical power that supports important electrical system on the loss of normal power supply, or you can say the power mains. And a standby power system mainly includes a generator, batteries and UPS. So let's see one by one. First is uninterrupted power supply, that is UPS. An uninterrupted power supply provides emergency power to the load when the input power source or main power fails. Now, what are the types of UPS? So, first is the standby UPS, next is the online UPS, and the third one is the line interactive UPS. So, let's see the types of UPS one by one. First is standby UPS. Offline UPS units are often referred as standby system as the inverter, as you can see in the diagram, is in standby mode until the main power supply fails. So now let us see how it works. As you can see the diagram A, under normal operating condition, the AC power from the utility passes the UPS through the UPS to the critical load, and a rectifier converts AC to DC to charge the battery. Now, when the main supply fails, as you can see in the diagram B, the inverter is used to convert DC power from the battery to create AC power to support the load. Normally, the inverter is operating in the standby mode, keeping the batteries charged. And so, when the utility power go out of specification, the inverter powers the load, draw energy from the battery. This topology is called as single conversion because the power is only being converted once, either it will be AC to DC or DC to AC. So this is standby UPS or offline UPS. Next is online UPS. This UPS provides the highest level of protection, and an online UPS absorbs the incoming AC supply, converts it to DC by the rectifier with the help of rectifier, and this rectifier provides rectified output, which is then inverted to AC supply by the inverter to supply the critical load. An inverter supplies the regulated AC power to the load at all the times, either from the rectified mains or from the battery. With an online UPS, in the event of blackout, there is no transfer time or break in the power supply, and this is because it contains an automatic bypass to ensure that continuous power supply is ensured during the failures. These units are often referred to as double conversion because they can convert AC to DC to DC to AC. So this is about the online UPS. Next is line interactive UPS. A line interactive UPS contains auto transformer, or you can say a buck boost converter that boosts the main power supply when it falls. So it can regulate the power to an acceptable level without the use of battery during the brownout or the surge in the supply voltage. Similar to an offline UPS, there is a short period when the line interactive UPS switches to the battery mode during a blackout. They provide the highest level of protection at an affordable price, and this category resembles the same as an offline UPS, but it inserts a transformer, or you can say an inductor, in series between the utility power source and the load. This inline inductor enables the UPS inverter to interact with the incoming power and provides a measure of power conditioning to the load, and this buck boost circuitry helps in the high and low input voltage conditioning. So this is about the line interactive UPS. Now let us see what are the selection criteria for UPS. First is output voltage. It is necessary to consider the size of load that is to be connected to the UPS. Once this is identified, the necessary rating of the equipment system can be determined. Next point is battery life. Now the manufacturer state the battery life for the UPS. However, the actual battery life is determined by how often the battery is used when there is an outage, surge, sag or swell. And each time the battery takes over, its useful life gets diminished. Next point is cost. If one is buying a more expensive unit, then the one should get with the software that automatically saves the data, closes the application, and turn off the computer equipment in advance before the UPS standby power goes out, following with the main failure. And the last criteria is additional features. There are some UPS available in market with the modem surge protection, electromagnetic interference, and radio frequency interference noise filter. So these are the additional features which can be used while selecting the UPS. Now next type of standby power supply or emergency supply is battery. A battery is a device consisting of one or more electrochemical cells with external connections for powering the electrical devices such as flashlight, mobile phones, and electrical cars, etc. The types of batteries are primary batteries. Primary batteries are the one which cannot be reused once it is being used. And the second is secondary or chargeable batteries. These batteries after its use can be recharged and used again. So first is the primary batteries. As I already said that the primary batteries are the batteries that cannot be recharged once depleted, and the example of devices using the primary batteries includes our wristwatch, remote controls, and some of the children toys. Next is secondary batteries. There are basically four major types of the rechargeable batteries. First is the lithium ion, next is the nickel cadmium, next is the nickel metal hydride, and the next is the lead acid batteries. So these are the major rechargeable batteries which are being used. So now let us see selection criteria for batteries. So first is voltage. This can be an issue in some equipment, although need not to be if it is designed for the chosen battery type. Next is discharge rate. Some type of battery discharge at a higher rate than the others. Lead acid batteries are used in vehicles because they can give a very high current for a short period, whereas alkaline batteries are designed for a long life and so are not intended to give a large current. Next point is self discharge. The rate of self discharge should be also considered as this affect their shelf life of the battery, and this occurs all the time including when the battery is not being used. And the last point, recharging. The number of times that rechargeable batteries can be charged and discharged depends upon the type of battery and the number of discharge and recharge cycle that a battery can provide without a significant loss of performance depends upon the type of batteries, and there can be a significant variations. So these are all the selection criteria for batteries. Next type of energy, next type of emergency or backup supply is the DG set, that is diesel generator set. A diesel engine is used as a prime mover in a DG set, which drives an alternator to produce the electrical energy. In case of a diesel engine, heat required for the combustion of the fuel is obtained by compression of air in the engine cylinder, and then the fuel is injected in the engine cylinder. In diesel power station, the mechanical energy is generated using direct combustion of the fuel under used. The diesel engine, the diesel power plant are more advantageous because of its initial cost, quick starting and stopping time, and it does not require any warm up period. Therefore, the standby losses are not present. Here in the DG set, the engine is the main component which develops the mechanical power, and the engine is directly coupled to the alternator, and the internal combustion engine may work on 4-stroke cycle or 2-stroke cycle. So now let us see what are the selection criteria for a DG set. So first is that the most important factor are the power and speed of the engine. So first point is power and speed requirement. The power requirement is determined by the maximum load. The engine power rating should be 10 to 20% more than the power demand by the end use. This is because this prevents the overload on the machine by absorbing the extra load during the starting of the motors or switching of some types of lightning system, or when the wear and tear on the equipment pushes up its power consumption. Next is speed. Speed is measured at the output shaft and given in the revolution per minute, that is RPM, and an engine will operate over a range of speed, with the diesel engine typically running at a lower speed, for example 1300 to 3000 rpm. So there will be an optimum speed at which the fuel efficiency will be the greatest, and engine should be run at as closely as possible to the rated speed to avoid the poor efficiency and to prevent the built-up of engine deposit due to the incomplete combustions, which will lead to the higher maintenance and the running cost. To determine the speed requirement of an engine, it will be depending upon the requirement of the load. Next is capacity combination. From the point of view of space, operation, maintenance, and initial capital investment, it is certainly economical to go for one large DG set than two or more DG set in parallel. If two or more DG set runs in parallel, can be advantageous as one of the shortfall in the power depending upon the extent of the power cut prevailing need to be filled up. Also, flexibility of the operation is increased since one DG set can be stopped while the other DG set is generating at least 50% of the power requirement. Another advantage is that one DG set can become 100% standby during the lean or low power cut period. Next point is cooling. It may be possible to have a air cooled engine in the lower capacity, whereas it will be necessary to go for the water cooled engine in the larger capacity to ensure that the engine does not get overheated during the summer months. And the last point is safety features. It is advisable to have a short circuit, overload, and earth fault protection in all the DG set. However, for a smaller capacity DG set, it becomes uneconomical. Hence, it is recommended to install a circuit protection. Other safety equipments like high temperature, low lubricant oil pressure cutout should be provided so that in the event of any of the abnormalities, the engine would stop and prevent the damage. It is also essential to provide reverse power relay when the DG sets are to run in parallel to avoid the backfeeding from one alternator to the another. So, these are all the selection criteria for a DG set. So, that's all